So I am going to assume that you know that Terraform is an infrastructure as code tool, which means that you can use a programming language of some kind, some code, to actually define what your infrastructure looks like, what your virtual cloud computing resources look like. In the case of Terraform, you use a language called HashiCorp Configuration Language, or HCL, which is a declarative language which is interpreted by the Terraform tool and translated into calls to AWS. I should say, for the purposes of balance, other cloud providers are available. So there are other tools that we can use for deploying functions, things like Zapper and Chalice, which are aimed at Python. Chalice with its lovely, familiar Flask-like syntax, of course. Apex is another one, and Serverless, which is arguably the most well-known one, which does lots of different cloud providers and languages, runtimes. So they're all great tools for deploying functions as a service. So why would you want to consider Terraform? So Terraform does multiple cloud providers as well. It's much more of a general infrastructure as code tool. So not only can you use it for multiple function as a service providers, but you can use it to define all of your cloud computing resources as well. So you've got the big three cloud platforms there, but it also does things like Datadog for defining your alerts. It does things like Fastly for your CDN. There are about 80 officially supported providers for Terraform, including things like GitHub and stuff like that, if you so choose. So it's very much a general purpose infrastructure as code tool. And in this instance, the platform that I'm going to be talking about contains a lot of containerized services, so services running in Docker on ECS clusters. And using Terraform lets us manage those services and the serverless components using the same tool. Today I'm going to be talking about scaling Terraform. Scaling Terraform on a platform which is used by over 100 developers, and the things to consider when you're doing that. This platform was built while I've been contracted at a company called Accurus, formerly called Merger Market. Their engineering department is made up of about 15 different Scrum teams, well over 100 engineers there. They have a really good engineering culture, and they care about doing things the right way, so it's a nice place to work. So we're talking about going from this small group of developers. They look very friendly. I'd probably like to work with any of them. I think I actually have worked with that guy over there, actually. Very nice people to work with, very friendly environment. Up to this, over 100 developers, absolutely terrifying, gaggle of dangerous devs, all with their own opinions, their own ideas, very intimidating. So scaling up to this kind of level is either going to be a fun challenge or a bureaucratic organizational nightmare, depending on how you're feeling that day. So why would you want to do that, or even need to do it? Operating a successful DevOps culture is going to require you to automate some tasks which would otherwise have been done manually. And creating infrastructure in AWS is not something that we want to be doing manually, particularly when it's done by 100 engineers. But you do want the team that writes the software to be responsible for running it. And at some point, that is going to involve the infrastructure. And they need to have as much control over that infrastructure as possible. So we could just give everybody admin access to AWS, right? And that'd probably be fine. Maybe not, maybe not. Over 100 people with admin access to AWS, you're probably going to spend most of the time putting out fires. So today I'm going to be talking about 3 things that we consider when scaling the use of Terraform across the organization and what problems they solve. We're going to be talking about modules, CI, and bundling. And don't worry about what exactly bundling is. We'll talk more about that once we get there. So modules. What are modules solving? When you're running infrastructure at scale, it's important that, as far as possible, everything looks the same. For a start, once a problem has been solved, you want everybody to have the benefit of that. You don't want teams to be continually solving the same problems, because what the hell are you paying these people for? How many designs of the wheel do we actually need? If you're running web services, then the infrastructure for them can look the same. There's no reason why it can't look the same, and so it should do. Engineers and products move between different teams all the time. So if you can avoid people having to learn a whole new way of the way something is run each time that happens, then you're going to save yourself a lot of time, and you're going to be able to do a lot more interesting things. It's going to be way easier to debug those services if all the logs are in the same places, if all the metrics are in the same format, if things are predictable. So as I say, this platform has a lot of Docker on ECS, but increasing numbers of serverless components as well, which use AWS Lambda. These Lambdas are triggered by cron schedules, the notifications from CloudWatch events, SNS topics, S3 events, and some API gateway as well. And everything is deployed using Terraform. And of course, then Terraform manages any of their associated infrastructure as well. Things like databases, things like S3 buckets, Elasticache clusters, SQS queues, things like that. Lambdas get built and zipped up and pushed up into S3. Docker containers, of course, get built and pushed into an ECR repository on AWS. And then the application gets deployed by running Terraform against some HCL. So imagine if there'd been free reign on this, and some teams had gone for fixed EC2 instances, and they'd FTP'd the code up there, and they'd run the application inside a screen session. You know, we've all done it, but we shouldn't be proud of that. When you're scaling organizationally, it's really tricky to make sure that all the teams have the same level of knowledge. So using technological solutions, we can avoid things happening which might make you feel a little bit dirty. Terraform has a mechanism for abstracting code, and then you can reuse that code. And those are Terraform modules. This example is for a VPC. And it's analogous to a function call. So I've put a similar example in Python down here. The Terraform module has inputs, the name and the CIDR range, and you can also get outputs from the module as well. And in between, some stuff happens which you shouldn't really have to care too much about. You don't know exactly what's happening when it creates the subnets, when it creates the routing tables and stuff like that. You just care that you get a VPC back that you can use. A module is just some files in a directory, and you can reference them either locally on your local file system or remotely. You can put them into S3, you can put them into the HashiCorp registry, and that source there is a reference to the HashiCorp registry, or you can put them into GitHub. And this is an example of a module referenced on GitHub. In this project, all of the modules that we reuse are on GitHub, and they're all publicly available on GitHub. The reason for that is because the Terraform registry didn't exist when we started this project. Now we would probably use the Terraform registry, and I think we will start to move modules into there, particularly if they're public, because it's a nice way to reuse the code. The modules can be composed, so you can have a module which uses other modules within it, and you can have multiple module calls alongside each other, of course, as well. And using that, you can break your infrastructure code down into discrete and reusable pieces in the same way that you might do with your application code. So if you think about Lambda and API gateway, this is a dependency graph from Terraform of a single API gateway with a single resource and a single Lambda behind it. So for that, in Terraform, you need to define an API gateway. You need to define a deployment for that API gateway. You need to define an HTTP resource, an HTTP method for that resource. You need to define a Lambda function. You need to define an API gateway integration with the Lambda function. You need to give permissions to the API gateway to run the Lambda. And plus, you need a lot of IAM permissions for each of them to write to CloudWatch logs so you can find out what's going on when things inevitably don't work at some point. And that's a hot mess. And I don't really want to have to think about that each and every time I deploy a new API. So, is there a solution, I hear you cry? Well, yes, I'm glad you asked that. There certainly is. We can use Terraform modules. We can put a Lambda into one module. We can put the HTTP resource and its method into another module. And we can put the API gateway itself into a module as well. And so then to deploy our API is just 3 module calls, which is a lot more manageable. We don't have to care so much about all the different connections, all the links between all these different resources. We just know that we have these modules. We have to know how to link those together. Adding a new resource in there with a new Lambda would just be 2 other module calls, one for the API gateway resource and one for the Lambda itself. Abstractions like this make it really easy for people to do the right thing. They save people time, but they also make sure that it's done right as well. And because you're interacting directly with Terraform, you have the power to override those modules if you need to. You can clone them locally and you can reference them there, and hopefully you'll contribute the changes back upstream so that everybody gets the benefit of your improvements. Modules get pulled in when you run Terraform init to initialize the project. And as long as that's done regularly, you can be sure that everybody is using the latest, most up-to-date version of the shared code when they deploy their infrastructure. That does mean, of course, you've got to be really careful about not making breaking changes. These modules have got to be really stable if you want people to be able to pull in the latest changes every time. OK, CI server. Why would we want a CI server here? So all the teams are using the same set of Terraform modules, the same set of reusable code. So we know that this base infrastructure is going to be sensible and it's going to be uniform. But who made changes last? Because there's an S3 bucket here, and its permissions are a little bit more liberal, a little bit more welcoming, a little bit more take all my data than perhaps we would want them to be. So who added that, and why did they do it? Was there a good reason for it? Who do we go to ask? Well, you're writing code to define your infrastructure, so you should treat it like you would treat any other code you write. And looking around, you all look like fairly responsible people. I'm sure you all check your code into version control. So do the same with your infrastructure code. Put the HCL files alongside the application if Terraform's doing the deployment for you. That's a pattern which I've used many times and works really well. Version control and the messages in the log give you your history of intent of those changes, a history of what you actually wanted those changes to be. And that's why good commit messages are good. I'm sure we've all seen commit messages which are just a dot or the letters F, F, and S. And they're not very helpful, even though at the time it might feel like that is your only solution and you just want to get it pushed out. Do tell your future self, this is what I actually intended this to do. It is going to help you. So run any changes that you make with Terraform on a CI server. Jenkins is something that we all know and presumably have other feelings about. So let's use that rat's nest of barely maintained plugins and unreproducible config to run Terraform and give you a visible log of the changes that it's made. I expect most people in the engineering organization to have at least read access to the build server. So they're going to be able to go on there and find its logs and actually see what Terraform's done. So your version control gives you a history of the intent of what you wanted those changes to be, and then your CI server gives you a record of what those changes actually were when they went out for real. Terraform allows you to preview changes as well. You can use the plan command, and that will look at any state that Terraform holds on what it thinks the state of your infrastructure should be, and then it'll go off to your cloud provider and just check what state those things are actually in. And then it'll look at the HCL that you've given it, and it will work out what changes it thinks it needs to make to put your AWS account, for example, into the state that you've requested. And you can use a gate on CI for that. So you can run the plan command, and then you can get it to send you a message in Slack or HipChat or MSN Messenger, whatever you guys are using to communicate. And then you can go and inspect that plan and approve it before it goes through to whichever environment you're deploying to. Having an environment before production is really good, because that's like an integration test for your whole code base, for your application and your infrastructure code. If you deploy it to staging and everything's still working, then that's a pretty good sign. If you deploy it to staging and the load balancer gets recreated, then maybe you need to go back and look at those changes. Your customers might not know what a load balancer actually is, but they probably will notice if it's not there. Look, I don't know exactly what my liver does, but if it wasn't there, I think I would probably notice. So bundling. And I said we were going to talk a bit more about what bundling actually is once we got there. You've got your infrastructure code, and it's composed of modules. We're all benefiting from other people's hard work, but we're taking the credit. We're where we want to be. The code is checked into version control, and it's run on CI. But we've just discovered that there's a Lambda function. The Lambda function module has actually given administrator access, the administrator access policy, to all of the Lambda functions. It's kind of the IAM equivalent of chmod 777ing everything and just hoping for the best. So we fixed that. We give it a more appropriate service role with suitable permissions for Lambda. The module is updated, but how do you make sure that everybody's using the latest version of that? We know that the modules are pulled in when we run Terraform init, but how often does that get run? So you should run it as a setup step on CI. When you get started with Terraform, the docs all kind of lead you to running it locally. And you do an init once, and that downloads everything that you need. And there's a command to upgrade everything, but how often are you going to run that? Who's going to enforce you running that on your local machine? When we're running on CI, Terraform init should be a setup step at the start of the pipeline, initialize every build to pull down the latest dependencies. You get the latest version of all those modules, and your Lambdas no longer have admin access to your entire AWS account, which I think we can all agree is a good thing. We're building this at a quite large scale, so we've got a cluster of build machines. And the deploy to your staging environment is a separate step in your CI pipeline before production. And the gap between going to staging and going to production is arbitrarily long. You know, we've already talked about having a gate there. We've already talked about going in and checking staging. Whether you have automated acceptance tests, or whether you want to actually go on manually and see what's going on, there's going to be some time before you then go to production. And if you're using a cluster of transient build machines, then there's no guarantee that you're going to get the same machine that you ran your staging build with. That might be long gone, another job might be running on it. We can't guarantee that. And we wouldn't want to, because that would contend that machine when you're going investigating what's gone wrong on staging. So we've already decided that each build needs to do a fresh initialization of Terraform so that we pull down the latest modules. How do we then make sure that those modules are consistent through the CI pipeline, and that we get the same version of modules in production that we used in staging? So this is our idea of bundling. At the start of the CI pipeline, after you've run Terraform in it, you introduce a bundle step. You zip up your HCL code, and you zip up the .terraform directory where all the modules are downloaded to, and you store that resulting archive somewhere to be used later. That could be S3, for example. So this is now a build artifact. This is like a jar or a Docker container or the Lambda archive that we zipped up and put in S3 earlier. And this is tied to this particular version of your software. So the continuous delivery idea said that you build your packages only once. This is one of the recommended practices for implementing continuous delivery. You build and package your software, and then you carry that through your pipeline. So you get the same thing in each environment. Each time you deploy that version, you're deploying the same thing that you built at the start. By bundling up the Terraform code and its modules, you're treating your infrastructure code in the same way that you would do your application code. You bundle its dependencies once, and then that gets carried through each environment. So these are three patterns which have given us the confidence to give almost complete control of the infrastructure to over 100 engineers, operating over about 15 different teams. And new teams are coming on all the time, so that number is growing all the time. There are a few things that I haven't covered, but which I do want to mention briefly. The network config, or any kind of shared configuration. This platform configuration, as we refer to it, is currently delivered as a JSON file, which is checked out of a Git repo at the start of the pipeline, and it's passed to Terraform as a map variable. And you can look up values in that map. So you can see we're looking up the VPC ID in the platform config there to create a security group to allow all traffic to MongoDB, which I don't think is a recommended security practice, but it is something which happens a lot. So people want an example of that. This works fine, but what I'd really like to see is this delivered as a Terraform module. So Terraform allows you to use data sources where it's not provisioning something, it's reading something from your infrastructure. And you can, with a lot of the resources, you can query them based on their tags or on their name. So if you have a predictable name for your VPCs or for your subnets, then you can use those Terraform data sources inside a module. And instead of having a hard-coded file with values in, you actually have a Terraform module which is dynamically looking things up and returning those as outputs from the module. I have done a proof of concept for this, and that worked, but it's not in use yet, so I can't say how well it works on a wider scale. It is going to involve you having all your other infrastructure in a really good shape. So if you have multiple VPCs in different accounts, then they all need to be named consistently and tagged consistently. You can use Terraform for that, of course. Damage limitation. If you're going to give control of infrastructure to a large number of engineers, then some mistakes are going to happen sometimes. Some of them are going to be bigger than others. So how can you give the devs as much control as possible while you limit the amount of collateral damage that can be done? So this is more AWS organization rather than Terraform. But the way that we do it is to have a pair of accounts, or pairs of accounts, should I say. So you have one account for the live environment, and you have one account for all of the other environments before that. And each pair of accounts has between 1 and n teams using it, where n is not all of the teams in the organization. So we have quite a number of account pairs, but the teams aren't equally distributed across them, as it's something we started doing in the past year or so. So teams have got full admin access to the accounts via CI. And they've got full read access to the accounts through the AWS console. And so that encourages everybody to make changes through the CI server so that you have your history of all the changes that have been made, but they can get in through the console to actually see what's going on in there. And we do have a wrapper script which assumes a role in the correct account depending on which account you're actually deploying into. And so I just mentioned a wrapper script as well. This script also sets up Terraform's remote state handling in a consistent way. When you run Terraform against your cloud infrastructure, it generates some state, it records what it's done, and there's a way to configure it so that it transparently pushes that state up into S3. And so that's something which is really, really useful if you're running on CI, particularly when you've got your transient build machines. You're not necessarily hitting the same machine. You just need to be able to know where to pull it down from S3. So we have a wrapper script to do that so that you don't have to think about exactly where you're putting it. It picks up values from the environment and puts that all in a consistent place. It also handles the bundling as well. I haven't given lots of time to this because it's changed since it was first created, and it's going to change again. It is intended for general consumption, but it's not ready for that at all yet. But that is what we use to do those things around Terraform to make it consistent. So if you want the organization to move quickly and for the teams in it to have the power to innovate, a DevOps culture is a really good way to do that. Using Terraform, you can give the developers a lot of control and, of course, a lot of responsibility over their infrastructure. And by using modules as abstractions and reusing those, then you encourage consistency as well. Continuous integration and version control give you your history of intent and give you a history of actual changes. And that's really, really beneficial when you're operating across such a large number of teams. And then if you bundle your dependencies up and push them through your CI pipeline, then you're essentially doing continuous delivery for your infrastructure code. And if you're deploying to multiple cloud providers, and if you're deploying different types of cloud resources, then Terraform is a really good solution for that. And we have shown that it can work at scale as well. Thank you.